Rishabh Negi, hi, very good evening. Anup Gayakwar Patel, good evening. Alok Kumar, good evening. Okay, now what is Gradeup Super? Gradeup Super is a subscription for unlimited access to all structured live courses and mock tests for CAT 20 and CAT 2021. All right, okay. Now, what is on agenda tonight? We have to discuss 12 important questions for CAT 2020 with an alternative approach. And every single time we take any session here in this series, we share all the questions with you in advance. Okay. Today also we have given you the PDF of the questions in advance. All right. I'm sure that all you people have already gone through these 12 questions and you have done them as well. Isn't that? Okay. All right. So we take this series ABC, which is extremely important for getting into IIM-Ahmedabad, Bangalore and Calcutta. That is in order to score very high in the quantitative aptitude section of the CAT. All right. And we take it every Sunday at 10 p.m. All right. On the YouTube. And when it comes to our app, we take it every Monday, Wednesday and Friday. Again at the same time at 10 p.m. All right. Okay. So let's move from here. Look at this question on the screen and kindly try to do it as soon as possible. I will read the question for you. Though I expect all of you to have done all these 12 questions well in advance, given n points in space, no 3 of which are collinear and no 4 are coplanar. For what value of n will there the number of straight lines be equal to the number of planes obtained by connecting those points? Is that clear to you? Please tell me the answer. Please do question number 1 to start with. Okay. Any response to question number 1? Any response to question number 1? And I repeat, we do this series every Monday, Wednesday and Friday at 10 p.m. on our app. Okay. I'm sure you have already downloaded our wonderful app. Okay. And on YouTube every Sunday at 10 p.m. Hi Binod, very good evening. Please do this question now. Solve this question. I'm not getting any response. I'm not getting any response here. All right. So let's do this question together. There are n points in space. All right. And no 3 of which are collinear. So how many points, how many lines can you draw? Binod is saying 40 is the answer. That is incorrect. So coming back to the question, if there are n points of which no 3 are collinear, so how many straight lines can you draw? You can draw NC2 straight lines, isn't that? And how many points do you need in order to determine a plane? In order to determine a plane, you require 3 points. All right. So if there are n points, how many different planes can you get? This is given that no 4 points are coplanar. All right. So number of planes would be NC3. So this is given that NC2 is equal to NC3. Okay, I'm sure all of you are aware of this, that NCR is equal to NC n minus R. So if we have NC2 is equal to NC3, that only means that n is equal to 2 plus 3, that is 5. Any doubt, anyone? Any doubt? Okay. So 5 is the answer to this question. Okay. All right, let's move to the next question. But before we move to the next question, I have a question for you. There is a very basic question in geometry. All right, that there is an n-sided convex polygon. Okay, and this polygon, this convex polygon, okay, has n diagonals. Okay, what is the value of n? There is an n-sided polygon, convex polygon, Okay, number of diagonals is also n. Number of diagonals is also n. Okay, then what is the value of n? Will anyone tell me? Will anyone tell me? Okay, I asked you a question. Okay, this we have already done. Here the answer is 5. My next question is, there's an n-sided polygon. Okay, and number of diagonals is also n. Okay, what is the value of n? I'm not getting any answer. I'm not getting any answer. Okay, there also, of course, the answer will be 5. In an n-sided convex polygon, what is the total number of diagonals? Total number of diagonals is n into n minus 3 divided by 2. And if this is given to be n, right, of course, n minus 3 is equal to 2 and n is equal to 5. Okay. All right. Let's move to the next question now. Let's move to the next question. Okay, here, of course, this is your solution to the first question. This is your next question. How many real solutions, x, y, I, both x and y are real numbers, does the following set of equations have? How many real solutions, okay, does the following set of equations have? X square plus 4 is equal to y cube and x plus y is equal to 16. How many real solutions does it have? It's a theta. Type in the answer. Okay, so you have no options. Mostly your answer is a numeral. Okay, it's a number. Okay, tell me what's your answer to this question. Tell me what's your answer to this question. Not getting any answer. Not getting any answer. Anup Gaikwad Patel is saying n is equal to side. That question is over now. Please concentrate on question number 2, Anshuman. Okay. And give me the answer. Give me the answer. Okay. Here also, let's do it together. Let's do it together. Okay. And we shall be looking at it from 2 different angles. In the examination, let's say I do not have much of time. First of all, keep this in mind that ultimately it will reduce to a cubic equation. A cubic equation will have 3 roots. Total number of roots of a cubic equation would be 3. Alright. And mind you, total number of imaginary roots will be either 0 or 2. Okay, because imaginary roots are always in conjugate pairs. Okay, if one of the roots is 2 plus 3i, another root would be 2 minus 3i, that is for sure. So imaginary roots will always be in conjugate pairs. So total number of imaginary roots will be either 0 or 2. Isn't that? So first of all, a cubic equation would have at least one real solution. Each and every cubic system, each and every cubic equation would have at least one real root for sure. Okay. So your answer can be 1. Okay. Can it have 2 real roots? No. Because if there are 2 real roots, it means only one root is imaginary. But that is impossible. So you cannot have 2 real roots. Can you have 3 real roots? Yes. Okay. So your answer is either 1 or 3. And this is theta. There is no negative marking. In the examination, if you're not left with much time, okay, just mark one of these 2, either 1 or 3. Alright, and move ahead. There is a 50% chance of you getting 3 marks. Alright, but of course, not that otherwise is a difficult question to do. I'm sure everyone can do it. Alright, and how would I do it? From here we get x is equal to 16 minus y. Alright, and 16 minus y whole square Okay, 16 minus y whole square plus 4 is equal to y cube. If you solve it, you will get just one real root, which is y is equal to 5. Okay, and x is equal to 11, obviously. The other two roots are imaginary, so answer is 1. There can be another way of looking at it. There can be yet another way of looking at it. Okay, that way is, look at these two. X plus y is 16 is a small number. Okay, but the difference between x square and y cube is 4. Okay, the difference between x square and y cube is 4. So what if I take something like y equal to, what if I take y equal to 8 and x is also equal to 8? 8 cube is 512 and 8 square is 64. So there's a huge difference. The difference cannot be of, okay, only 4. So one thing is obvious, that x has to be kept higher. Okay, because of a big number, the cube will become much bigger. Okay, so y has to be small and x has to be large. So can we try 10 square, okay, and 6 cube? 10 square and 6 cube, 100 and 216. Still you have 116. Okay, what about 11 square and 5 cube? Okay, 121 and 125, the difference is 4. This could be another way of looking at it. Okay, all right. Any doubt? Any doubt, anyone? All right, so let's move to the next question then. Here, of course, the answer is 1. And this is where we have, of course, solved the equation. Okay, you can take a screenshot if you're really desirous of this. Okay, to me, this is not important. Let's look at this wonderful question. Let's look at this wonderful question. The principal of a college issues an order that for administrative reasons, every student of the college must take exactly 4 of the 7 courses offered in a semester. In addition, he also wants to ensure that each course has the same number of takers. If the actual number of students is 53, at least how many of the students would have to leave the college to make the principal's plan feasible? All right, I expect all of you, each one of you, to do all these questions before you come for the session. Okay, this session is definitely not for time pass. Tell me what's the answer. Tell me the answer. All right, let's start doing it together. Let's start doing it together. This is clearly given. The total number of courses is 7. Okay, and this also is given that each and every student takes up exactly 4 courses. Let's assume that for our purpose we require n students. Okay, and this also is given that each and every course is taken up by the same number of students. So let's assume that each and every course is taken up by x students. So that way, course student combo. All right, how many course student combos are there? 7x. Because there are 7 courses and each one of the courses has been taken up by x people, so 7x. Now let's assume that for our purpose n students are needed, overall n students are needed, and each and every student takes 4 courses. So that way, course student combo is 4n. All right, luckily this 4n has to be equal to 7x, isn't that? 4n has to be equal to 7x, and n will be what? Will be 7x divided by 4. Now look at the value of n. Since n has to be 7x divided by 4, now of course this 4 is not going to cut short 7. This x has to be a multiple of 4 in order to make n an integer. Alright, this x has to be a multiple of 4. So overall n, if n is equal to 7x by 4, n has to be a multiple of 7. N has to be a multiple of 7. Okay. Now the question is, at least how many of the students will have to leave the college? Right now the total number of students is 53. Right now the total number of students is 53. But in order to make principal's plan feasible, total number of students should be a multiple of 7. Nearest multiple of 7 is 49. And the question is, at least how many of the students would have to leave? So, at least how many students will have to leave? 4. Okay? At least 4 students will have to leave. So, 4 is the answer. Any doubt, anyone? Any doubt? Any doubt? Some people, Vinod, Alok, they have said 18. Okay, even if 18 students leave, that will be right. Okay, principal's plan would be feasible. But the question was, at least how many of the students will have to leave the college? At least 4 students can leave, 11 students can leave, 18 students can leave. Right? So here the answer is 4 and not 18. I do not know how did you get 18, 2 of you. Okay, any doubt? And if you're enjoying the session, please do like it and share it as well. Sharing is caring. Haven't you heard? Okay. So of course, here the answer is 4. Any doubt, anyone? Alok, Binod, any doubt? Okay, Vivid Learning is saying that now 14 I shared with my friends. Thank you, Vivid Learning. Okay. Now, let's move to the next question. It's a very interesting question. Very interesting question. And most important thing is that it can be done in a jiffy. A teacher writes 101 numbers on the blackboard. Wow. Very patient teacher. Of which 50 are zeros and 51 are ones. A student is asked to perform the following operation 100 times on the board. Strike out any 2 numbers. If they're equal, write another 0. If they're unequal, write a 1. What are the numbers left on the board? Please do read the question and please solve this wonderful question. Okay? I do not think that there is any difficulty, okay, in understanding of this question. It appears that many people are lost in watching the T20 match being played between England and that nefarious country Pakistan. Okay. Any answer, anyone? Any answer, anyone? Okay. Not getting any response. Let's do it together. Let's do this also together. How many zeros you have? You have 50 zeros here. Okay. 50 zeros. And how many ones do you have? 51 ones. And what is the operation? If you remove 1 and 1, okay, you put a 0 here. If you remove 0 and 0, again you put a 0. But if you remove 1, 1 and 1, 0, you put back 1. Okay. But one thing is for sure, you strike out 2 numbers but put back 1. If you strike out 2 numbers and put back 1, so slowly and steadily, the numbers on the board will keep decreasing. Initially, you have 101 numbers. Okay. Every operation reduces the number of numbers by 1. So after 100 operations, only 1 number would be there on the board. Okay. So of course, option C is ruled out. And if after 100 such operations, only 1 number would be on the board, it will be either single 1 or a single 0. So there is no question of none of the above. Okay. Ankut Verma is saying B. Ram Pratap Singh is saying C. Alok Kumar is saying C is the most stupid option. I agree, Alok Kumar, for a change. Ashutosh Pandey is saying A. Alright. the way I look at this question, is interesting. Okay. Let's assume, okay, that every single time you perform an operation, you strike out two numbers, you put back one. What do they say? They say if you remove 1, 1 and 1, 0, you put back 1. If you remove 1 and 1, you put 0. If you remove 0 and 0, you put 0. Okay? So the operation is of subtraction. I will assume the operation to be of subtraction. Okay? And you have to go, when you do the operation, okay, you just put the absolute difference between the two numbers. The absolute difference between 1 and 1, 0. Absolute difference between 0 and 0, 0. Absolute difference between 1 and 0, 1. Okay? So that is how you look at it. So you have 51 ones. Okay? And how many zeros? 50 zeros. So forget zeros. This entire operation will ultimately leave you with 1, 1. Why? Because even number of ones, they will all be eliminated. Okay? So that is one of the ways of looking at it. Okay, that you consider the operation to be of subtraction. Okay, because when you remove 1 and 1, you put back 0. When you remove 0 and 0, you put back 0. When you remove 1 and 0, you put back 1. Another way of looking at this, okay, in place of zeros and ones, assume that 1, 0 is equal to a positive sign and 1 is equal to negative sign. Okay. Now look, positive into positive, what do you get? Positive. Okay. So 0, 0, you put back 0. Negative into negative, okay, what do you get? You get 0, you get positive. Okay. So 0, 0, you get 0. 1, 1, you get 0. Okay. But positive into negative, what do you get? You get negative. There is 1 here. Alright. So if you do the entire operation just once, you have how many positives? You have 50 positives and 51 negatives. So this entire product will leave you with 1 negative. Over. Okay, and negative is equal to 1, so you would be left with 1, 1. Any doubt? Any doubt? So answer is not B for Binod, the answer is A for Alok. Okay? Yes, Jatin Agrawal, absolutely correct, Jatin sir. Alright, so let's move to the next question. Is the match between Pakistan and England over? I'm sure all of us are British tonight. Okay, we all want Pakistan to lose, undoubtedly. Okay, but anyway, let's come back to this question. The next one, of course, here the answer is A. Look at this question. Question number 5, and please try to get the answer as soon as possible. XYZ is a given triangle, right angled at the vertex Z. This is right angled at Z. ZM is perpendicular from Z to the side XY. The point M is at a distance 3 meters and 4 meters from the sides XZ and YZ respectively. Then the length of XZ is your 4 choices: 6.25 meters, 6.6 meter, 5.75 meter and 6.5 meters. What's your answer? What's your answer for question number 5? Tell me, and tell me fast. Tell me fast. Jatin Agrawal is saying A. Alok Kumar is also saying A. Okay. Anyone else? Any other answer? Anyone? And the good news is that England beat Pakistan by 5 wickets. To hell with Pakistan. Okay. Alright. So, only 2 answers thus far. Ashutosh Pandey is also saying A. Okay. Please keep the figure in mind. You do get lots of such questions in the examination. Okay. Of course, the answer is A. Look at this figure. Look at this figure. You in fact do not have to do much. You need to know, okay, you need to know this length. This is the length which you need to determine. And mind you, this also is 90 degree. Okay, so in the right angle triangle ZMX, this is MA, okay, is perpendicular to the hypotenuse. So of course, let this part be y, let AX be y. So one thing is for sure, that 3 square is equal to 4 into y. Isn't that? In any right angle triangle, this 3 square, if MA is perpendicular to XZ, which it is, right? MA square would be ZA into AX. Okay, so 3 square is 4 into y. So 9 is equal to 4 into y. So of course that is obvious that y is 9 divided by 4, that is 2.25. So 4 plus 2.25, that is 6.25. It's as simple as that. Any doubt? Any doubt? Okay, so Ankut Verma also got A, so did Ram Pratap Singh, so did Utkarsh Srivastav. I'm very glad, very glad. Okay, let's move to the next question then. What do you say to this? Question number 6. We are interested in 3 positive integers a, b, c such that a square plus b square is equal to c square. Okay, there are many Pythagorean triplets. Alright, an integer pair b, c exists whenever a is a. BC will exist whenever a is. Come on, it's a very simple question, but I need to, or I have to teach you a lot here. Tell me and tell me fast. What's the answer to question number 6? What is the answer to question number 6? Vijay Singh is saying C. Okay. Any other answer? Any other answer? We have a lot to discuss here. We have a lot to discuss here. Any other answer here? Anyone? Okay, let's do it together. We all know that Ashutosh Pandey is saying D, none of the above. Okay, Jatin Agrawal is saying A, Abhijit Singh is saying C. So we have 3 responses, all 3 are different. Alok Kumar is also saying D. Okay, we are interested in 3 positive integers a, b, c such that a square plus b square is equal to c square. An integer pair BC exists whenever a is. Isn't it very obvious, very obvious that the answer is A, B and C. Whenever A is a multiple of 3 square plus 4 square, isn't that 5 square? Take any multiple. Of course, 6 square plus 8 square will be equal to 10 square. So isn't A always correct? Whenever A is a multiple of 3, okay, B will be a multiple of 4 and C will be a multiple of 5. So why would it not be correct? Okay, what is the question of D being the answer or C being the answer? Okay, what is the problem with option B? Let's look at that. Okay, the problem with option B is A, B and C. Whenever A is odd, what if A is 1? Okay, can you have A 1 square plus B square equal to C square? Do you have 2 consecutive perfect squares in the number system? So of course this is very incorrect. Okay, option C says prime. Alright, A, B, C. Okay, if I put 2 here. So 2 square plus b square equal to c square. Kindly give me one b and one c. Okay, which satisfies this. You cannot get any pair BC for which 2 square plus b square will be c square. So this is incorrect, this is incorrect, this is of course correct. Why would the answer be none of the above? Okay. Now please keep one more thing in mind. Please keep one more thing in mind. That except for one, alright, whenever you have an odd number, you will get a Pythagorean triplet. That is very important. Look, 3, 4, 5. 3 square plus 4 square, 5 square. Okay, 5, 12, 13. 5 square plus 12 square is 13 square. Okay, 7, 24, 25. Of course, 7 square plus 24 square is 25 square. Then 9, 40, 41. 9 square plus 40 square is 41 square. Should always be in your mind, right? 11, 60, 61. Okay, please never forget this. Never ever forget this. I will give you a generalized form as well. Okay, 2n plus 1 whole square, okay, plus 2n into n plus 1, okay, whole square, okay, is equal to, okay, 2n into n plus 1 whole square. Okay, so here n cannot be 0, but whenever n is 1, 2, 3, 4, whatever, so a can be any odd number. Here this a can be any odd number except for 1, and please never forget this. Okay, it's because of this that you keep getting these pairs, 3, 4, 5, okay, 5, 12, 13, okay, I've already told you, 7, 24, 25, never forget this. This is extremely important. You can derive it so easily. Okay, any doubt? Any doubt? Okay, now let's move ahead. So that is your question number 6. Of course, answer is A. Okay, this is the story which I was telling you actually. Look at question number 7. Come on, do it fast. Do question number 7 and do it fast. Very fast. Do question number 7 very fast. Okay, a key is manufactured by cutting incisions of different depths in a number of positions on a bank key. Be very careful. This key belongs to a bank. I will read it again. A key is manufactured by cutting incisions of different depths in a number of positions on a bank key. If there are 8 possible depths, okay, the number of positions required to make 1 million different keys is a very simple question. Okay, don't you see that in keys, in many keys, okay, you have many positions here, okay, and in all those positions, okay, there can be different kinds of incisions, all right, and there are 8 possible depths. There are 8 possible depths for each and every place. So the number of positions required to make 1 million different keys. Okay, 1 million different keys. 1 million is 10 lakhs, 10 to the power 6. Alok Kumar is saying B. Ashutosh Pandey is also saying B. Ram Pratap Singh is saying B. Ankut Verma is saying B. Utkarsh is also saying B. So I do not think that I need to discuss it any further. But still, for rest of you, let there be n positions. Okay, let there be n positions. In the first place, okay, how many depths are possible? 8. In the second place, 8. In the third place, 8, like this. So how many different keys will you be able to make? 8 to the power n. And this 8 to the power n has to be greater than equal to 10 lakhs. Okay. Now here, we all know that 8 cube is 512. Okay, so 8 to the power 6, mind you, this is 512, so around 500. 500 square would be what? Would be slightly above 2,50,000. 500 square would be what? 500 square would be 2,50,000. Any doubt? Okay, so 8 to the power 6 itself is greater than 2.5 lakhs. The moment I go for 7, I multiply both the sides with 7. 2.5 lakhs into 7 will certainly be above 10 lakhs. So the minimum value of n is 7. Any doubt? Any doubt? Okay, so let's move to, this was a simple question. Let's move to the next one. In a theatre, out of 1 lakh spectators, 51,500 are female and the rest are male. No third gender here, no transgenders. All right. Among the female, 9,000 are bald. Okay, that's very rare. Okay, it's very rare to get a bald female, but okay. And among the males, 30,200 are bald. Then choosing a person at random, the chance of getting a bald person or female is. Should be able to do it like this. It's a simple question. Okay, please do it and do it fast. Come on, do it and do it fast. In a theatre, out of 1 lakh spectators, 51,500 are female and the rest are male. Among the female, 9,000 are bald. Among the males, 30,200 are bald. Then choosing a person at random, the chance of getting a bald person or female is. Neeraj Mishra is saying B. Vinod Tharo is saying, Vinod, how can Vinod be the answer? Alok Kumar is saying A. Any other answer? Anyone? Ashutosh Pandey is also saying A. Alright, you have 1 lakh spectators. Okay, so in fact, this number, okay, is not even important. What are you looking for? Choosing a person at random, the chance of getting a bald person or female. What is the total number of females? Okay, total number of females is 51,500. Okay, we have already taken all the females. Okay, we do not have to think about the 9,000 bald females separately. Okay, and among the males, how many are bald? 30,200 are bald. 30,200. Okay, so how many people are either bald or female? Okay, 81,700 are either bald or female. Okay, so if you pick a person randomly, okay, the chances of that person being bald is 81,700 divided by 1 lakh, which is 0.817. Okay, you cannot get a question easier than this. But many people would not even attempt it in the examination, alright, thinking that this is a difficult question of probability. That also is a problem. That also is a problem. Okay, so let's move to the next question then. Of course, A. Any doubt here? Anyone? Any doubt here? Okay. Tell me about this question. A triangle has sides of length A, B and C. A is greater than or equal to B, is greater than or equal to C, and its area is 1. Then B cannot be less than. Then B cannot be less than. A triangle has sides of length A, B and C. A is greater than or equal to B, is greater than or equal to C, and area is 1. Then B cannot be less than. Okay. I do not want to discuss the so-called proper method. It can be done in 2 seconds. Tell me, how would you do it? Tell me, how would you do it? Any answer here? Any answer here, anyone? Guys, please concentrate on this question and not on Neeraj sir. Okay? I will keep a live session by Neeraj sir very soon, because it appears to me that there is a big fan following of Neeraj ji. Okay, or probably I will call him here and both of us will take the session together. Okay, concentrate on this question. What is the answer? I'm not getting any answer, and I'm not interested in any theory here. Okay? Alok Kumar is saying C. Utkarsh Srivastav is saying D. Any other answer? Ram Pratap Singh is saying D. Utkarsh D. Ram Pratap saying D. Neeraj Mishra D. Ashutosh Pandey D. Okay. Ankut Verma A. Alright. Alright. This appears to be a difficult question, but can be done in 2 seconds, as I said. What is the area of the triangle? 1. Okay. Can I very easily think about a right angle triangle? Okay. Okay. Right angle here. This is A and this is B. Okay. Half AB is 1. AB is 2. Can we have A equal to B equal to root 2? That is, can we have this triangle, okay, where this is root 2, this is root 2, okay, and this side is 2. Is that possible? So B can certainly be root 2. B can certainly be root 2. Root 3 is bigger than root 2. 2 is bigger than root 2. Okay. So root 2 is possible. How on earth can you mark anything other than root 2 here? How on earth can you mark anything other than root 2 here? Okay. And I'm of course not interested in that mathematical solution. Okay. Yes, Faz Alam, you're right. Okay. All right. Let's move to the next question. Question number. This is the triangle for you, of course. Tell me about this. A canal is surrounding a circular city of diameter 4 kilometers. 4 lampposts are located on the border of the city close to the canal at locations A, B, C and D, such that a direct path from A to C cuts another direct path from B to D perpendicularly at a junction E. The value of EA square plus EB square plus EC square plus ED square is what? Yes, guys, tell me. Okay, Vinod is saying, sir, you're doing it wrong. It should be half BC. Okay, I do not know. I do not remember. What did I do? Let me see. What did I say? After putting a triangle, okay. Acha, A, B, okay, and C. C has to be the largest. Oh, acha, what he is trying to say, interesting, that when I made the triangle, okay, please try to understand the concept, okay, it doesn't matter actually, but I should have been careful. This will be A, this is B, and this is C, is right. A has to be the largest, okay, so this is how I should have put it. Rather than putting half BC, I put half AB, and that is what his objection is to, okay. So BC is equal to what? 2. Alright, so of course, B can be equal to C can be equal to 2. Done? Happy? Okay. Let's come to this question. What is the answer? Ankut Verma is saying A. Alok Kumar is saying D, 32 square kilometer. Ashutosh Pandey is saying C. Utkarsh is saying C. Ram Pratap Singh is saying C. Again, I'm not interested in solving this question, needless to say. Okay. Let's say this is your circle. Okay. That a direct path from A to C, okay, A, B, C, D, that a direct path from A to C cuts another direct path from B to D perpendicular at a junction E. All right. This is A, this is C, this is B, this is D, and this is E. That is what you have. That is what you have, right? The value of EA square plus EB square plus EC square plus ED square. Okay. Mind you, you have not been told anything about AC and BD. You have not been told anything about these paths AC and BD, and you have not been told anything about point E as well. Okay, so can we do one thing? Can we do this? Let AC, okay, and BD be the diameters, okay, intersecting at an angle of 90 degree at the center. How do you rule it out? This also is possible. AC, BD. Okay. So this is 2, this is 2, this is 2, and this also is 2. Why? Because this is very clearly given that the diameter is 4. If the diameter is 4, radius will be 2. So EA square is 4, EB square 4, EC square 4, ED square 4. 4 into 4, 16. C is the answer. Okay, and mind you, I haven't even solved it. I do not have to. I haven't even solved it. I do not have to. Any doubt? Any doubt, anyone? Okay. Yes. So let's move to the next question. Yes, this is what I was trying to say. What about this one? The Institute of Perfect Management uses a unique scheme in generating roll numbers for its students. Each roll number has 4 distinct digits, where the first digit is never 0, of course. In a 4-digit number, the first digit will not be a 0. The maximum number of students who can be assigned roll numbers using this scheme is, tell me and tell me fast. Let's come to question number 11 now. What's your answer? What's your answer? And how fast can you get it? Again, I believe you can get it in 2 to 3 seconds. I believe you can get it in 2 to 3 seconds. Yes, guys? Okay, let's do it very fast because the next question will take us a bit of time. 4-digit number. Okay. Now, how many numerals you have? You have 10 numerals, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. You cannot put 0 here, so this can be filled in 9 ways. 1 you have already used, now you are left with 9, so this can be filled in 9 ways. This can be filled in 8 ways, this can be filled in 7 ways. And if you try to get the product, you are a fool. If you try to get the product, you are a fool. Because 9 into 9 is 81 and 87 is 56. So the last digit 1 into 6. There is only one option where the unit digit is 6. That's the answer. 9 into 9 into 8 into 7 will end with 6. There is only one such option. Straight away go for that. Do not even try to multiply. Right? Let's move to the next question then. Let's move to the next question. Yes, now this is a good question. This is a good question. 5 chairs labeled 1, 2, 3, 4, 5. Mind you, these are 5 chairs and they are labeled 1, 2, 3, 4, 5. are arranged round a circular table with equal spaces between them. A seating plan for 5 persons A, B, C, D, E is described as like this. C is on chair number 1, A is on chair number 2, B is on chair number 3, D is on chair number 4 and E is on chair number 5. Okay, and there is one more thing. 2 seating plans are considered identical if one plan can be obtained from the other by moving everyone the same number of places to the right. Okay, then the total number of non-identical seating plans is. Then the total number of non-identical seating plans is. Yes, Binod, please do this question. If there is any problem in understanding the question itself, please do let me know. What's your answer to this question? Eagerly awaiting your answers. Needless to say, you do get such questions in CAT. I'm yet to get any answer. Shall we do it together? Shall we? Vinod is saying A. Utkarsh is saying A. Ashutosh Pandey is also saying A. Okay. Everyone is saying A. So look, this is clear. This is clear. First of all, in how many ways, even if these 5 chairs, okay, are around a circular table, okay, so what? All 5 positions are distinct. All 5 positions are distinct. So 5 people A, B, C, D, E on these 5 chairs can be seated in 5 factorial, which is 120 ways. Right? But if A is sitting here, B is here, C here, D here and E here. If I move everyone, if I move A to 5, okay, that would be identical. Similarly, if I move A to 4 or A to D or rather A to 3 or A to 2, all such positions would be identical. So out of these 120 ways, okay, for every one particular arrangement, there are 4 more. Okay. All right. I will explain this further to you. Okay. By giving you this example. First of all, this is very clear to you that 5 people A, B, C, D, E can be seated on these 5 chairs 1, 2, 3, 4, 5 in 5 factorial. That is 120 ways. Right. Now look here. Of course, answer is A. Okay, A, B, C, D, E in these 5 positions. Okay. Similarly, if I move everyone A to chair number 2, okay, B 3, C 4, D 5, and of course E to 1, or this, or this, or this. These 5 positions, they are all identical. Okay, so every 5 identical position give you only one unique case. So total number of ways would be 120 divided by 5, which is 24. Okay. And this also, let's come back to the question. This also, okay, is needed only for those people who are not very clear conceptually. This is tantamount to saying, identical positions are tantamount to saying that at this stage in this circular arrangement, chairs are all numbered. If we remove those numbers, if 1, 2, 3, 4, 5, those numbers are removed, how many arrangements would be there? We know, then the answer will be factorial 5 minus 1, which is factorial 4, which is 24. Simple. Alright? Any doubt? Alok Kumar, it's not B, it's A. Okay? Alright. Now, before we go, this is the question for you. Okay, once the streaming is stopped, okay, comments section would be activated. Please do answer this question. For how many pairs of natural numbers, okay, the product is 2020, that is this year. For how many pairs of natural numbers, the product is 2020. And mind you, in every such pair, let's say in one particular pair, you have A and B. Okay, A and B should be co-prime to each other. A and B should be co-prime to each other. Alright, so for how many pairs of co-prime natural numbers, the product is 2020. Please put your responses in the comments. Alright, okay, what else? And what are the courses which we have at this stage in our super subscription? We have Score 99 Plus, a comprehensive course for CAT 2020. Okay, similarly we have CAT 2020 Retakers Batch. Upcoming courses, a comprehensive course for CAT 2021. Wow. Okay. And all this were in Gradeup Super. Okay. What else? We have many free series as well on Gradeup app. Mission CAT 2020, a free series of important topics. Decoding different types of RC questions. Wonderful. Then we have the ABC series. Okay. Something like this, which is there every Monday, Wednesday and Friday at 10 p.m. Okay, and series ABC is for getting into IIMs A, B and C. Master DI, important tools to excel in data interpretation. Okay, and our free series on YouTube, Mission CAT 2020, a free series for important topics, and ABC series, which is there every Sunday at what time? At 10 p.m. What else? Meet our faculty members, the great Vikas Dahiya, Jatin Agarwal, Savitri Ma'am, okay, Ashish Tiwari, Sanojam Dasubanta, Pranab Pant. All of them, without any exception, have been high achievers on CAT. Okay? Grade up, prep smart, score better. Good night.